There's this thing that happens when you've been awake since 4 in the morning, stress drinking bad coffee, and staring at a CAD model that refuses to cooperate. You stop believing the day can surprise you. You just go through the motions. You show up. You present. You nod at the right moments. And then you go home and do it all over again. That was supposed to be my Tuesday. I'm going to tell you what actually happened instead. My name is Tariq. I'm a postgraduate engineering student at Imperial College London, Water Systems, Civil Infrastructure, Disaster Response Design. Boring title, I know. But the work itself matters to me more than I can really explain without sounding like a charity brochure, so I'll just say this. I grew up in a part of the world where clean water wasn't a guarantee. It was a lottery. And that's the reason I ended up where I did, hunched over pressure flow simulations at 2 in the morning, arguing with my supervisor about membrane porosity and filtration rates. Our research group, 7 of us, plus our supervisor Dr. Anand, had been shortlisted for something called the Commonwealth Infrastructure Innovation Review. A mouthful. Basically, a panel of policymakers and technical experts that evaluate student-led engineering projects with real-world applications. We'd submitted our prototype 6 months earlier, a low-cost, gravity-fed water filtration unit designed specifically for use in post-disaster zones. No electricity required, compact enough to be airdropped in a standard supply crate, replicable using locally sourced materials in most developing regions. We were proud of it. We were also completely exhausted. The shortlist notification came by email, and I almost deleted it thinking it was spam. The subject line said, "Selected, Advisory Session Participation, Clarence House, London." I remember sitting in the lab kitchen, holding a lukewarm mug, reading it 3 times. Then I walked back to the main room and said out loud to nobody in particular, "Guys, I think something's happening." Priya looked up from her laptop. She had that look she always gets, half irritated, half curious. What kind of something? I turned the screen toward her. She stared at it, read it, stared some more. Is this real? I genuinely didn't know. We spent the next 48 hours in a strange kind of suspended disbelief. Dr. Anand confirmed it was legitimate. There had been official correspondence with the university administration that we hadn't been told about. Apparently because nobody wanted us to get distracted in the final weeks of our prototype testing phase. When he finally told us, he had this expression I'd never seen on him before. Something close to pride, but also something that looked almost like nerves. They want to see the filtration unit, he said, and they want to hear from you directly, all 7 of you. We had questions, a lot of them. Who exactly would be in the room? What format was the session? Was this a competitive presentation or more of a round table? Dr. Anand answered all of them patiently. And then, almost as an afterthought, he mentioned the one detail that made the room go completely silent. Prince William will be attending. He's been personally involved in the review process. It's connected to his Earthshot Prize Infrastructure Working Group. He's not there as a figurehead. He wants to have an actual conversation. Nobody said anything for about 4 seconds. Then Marcus, our structural engineer, the one who never gets flustered about anything, put down his pencil and said, very quietly, "Right. Okay then." That was Tuesday morning. The session was scheduled for Thursday at 10. We had 36 hours to prepare. I want to try to describe what London felt like that Wednesday evening, because I think the atmosphere matters to this story. It had been raining since lunchtime, not the dramatic kind of rain, but that gray, persistent London drizzle that soaks through everything slowly and makes the city look like an old photograph of itself. The streets around South Kensington were slick and dark, the streetlights cutting orange lines across the wet pavement. We were still in the lab at 8 o'clock, running final checks on the portable unit, making sure the seals held, the pressure valves behaved, the output flow rate was consistent. Priya was recalibrating the ceramic filter stack. James was reworking the assembly diagram to make it cleaner for a non-technical audience. I was rehearsing talking points in my head while pretending to review data, which I'm fairly sure fooled nobody. "You're doing the thing again," said Nadia, without looking up from her workbench. "What thing?" "The thing where you look at the spreadsheet, but your eyes aren't moving." I closed the laptop. "Are you nervous?" she asked. "I'm fine." "You've said membrane integrity 6 times in the last hour in completely unrelated conversations." "Fair point." The truth is I wasn't just nervous about presenting to royalty, though yes, obviously, that was part of it. I was nervous because this project meant something. Our filtration unit wasn't just an academic exercise. It was designed for people in genuine crisis, communities in flood-hit regions, earthquake zones, conflict-affected areas where the water supply had been compromised, and the window for preventing a public health catastrophe was narrow. We had designed it, debated every component, argued over cost per unit projections at midnight because we wanted it to actually work, actually be used, not sit in a journal and collect citations. This was potentially a room that could change that, and I didn't want to waste it. We left the lab just after 9. The rain had softened to almost nothing. Marcus walked alongside me for a while without saying anything, which is his way of being supportive, and I appreciated it. At some point he said, "You know what I keep thinking about?" "What?" "My grandmother used to carry water from a well every morning, half a mile each way." I looked at him. "She was 63 when I last visited her," he said, "still doing it." I didn't say anything. There wasn't really anything to say. We walked the rest of the way to the tube in silence, and somehow that said everything. The morning of Thursday arrived the way important mornings always do, too quickly and with too much clarity. I woke at 5:30 without an alarm, lay there for a moment listening to the city outside. A bus, pigeons, the distant sound of someone's bin being collected. I got up, showered, put on the one decent blazer I own, and told myself firmly that this was just a conversation. It was not, in any meaningful sense of the word, just a conversation. But you tell yourself these things. We gathered outside the lab at 8, all 7 of us, plus Dr. Anand. The unit was packed into its transport case, a gray, hardshell affair that looked ordinary enough. Like camera equipment or a musical instrument. Nobody walking past us on the pavement would have guessed it contained a gravity-fed water filtration system, capable of producing 200 liters of safe drinking water per day from heavily contaminated sources. Dr. Anand looked at us, adjusted his glasses, said, "Right, let's go show them what you've built." We took the tube to Green Park and walked the rest of the way. And I remember very clearly the moment we turned a corner and the outline of Clarence's house came into view through the trees, flags moving slowly in the morning air, the stone of the building pale and solid against an unexpectedly bright sky. The rain had gone. Everything looked clean and sharp, the way London sometimes does after a night of weather, like it's been reset. Priya, walking beside me, said softly, "This is real, isn't it?" It wasn't really a question. "Yeah," I said, "it is." She nodded once, straightened her shoulders. And we walked in. The security process was thorough and calm. Bags scanned, IDs checked, a brief but professional walkthrough with the liaison team. The transport case was inspected. One of the staff members asked a few technical questions about the unit's components, clearly briefed in advance. We answered them. The unit passed without issue. We were shown into a waiting area inside the building, a room that managed to be formal and unexpectedly warm at the same time. High ceilings, natural light, a few chairs arranged around a low table. There was tea already set out, which I suspect was a deliberate act of mercy toward a group of extremely strung-out engineering postgraduates. We sat, we drank tea, we spoke very little. James kept rotating his pen between his fingers, which is his anxiety tell. Nadia was reviewing her notes on her phone. Marcus was looking at the ceiling. Dr. Anand, to his credit, looked completely composed. I have no idea how. Then a member of the coordination team appeared in the doorway and said, simply, "We're ready for you." We stood, gathered ourselves, picked up the case, and walked through the door. The room we entered was not what I expected. I think I'd imagined something very grand and formal, a long table, chandeliers, the architectural weight of institutional authority pressing down on you from every angle. But it wasn't like that. It was a working space. Oval table, a row of chairs, natural light from tall windows, a screen on one wall for presentations. There were perhaps 12 people already seated, policy advisors, technical representatives, members of the review panel. People with folders and glasses of water, and the general air of people who take their work seriously. And at the far end of the table, standing rather than sitting, talking quietly with someone from the panel, Prince William. He was taller than I'd somehow expected, more relaxed in posture. He was wearing a navy suit, no tie, and he had the manner of someone who is paying genuine attention to what the other person is saying rather than waiting for his turn to speak. When we came in, he glanced over, and the thing that struck me immediately was that he didn't do the thing I'd braced for. He didn't look at us the way people sometimes look at students entering an important room. That small, practiced, charitable smile that says, "How lovely. Here are the young people." He looked at us the way you'd look at colleagues who have just arrived. Straightforward, interested, ready. He crossed toward us, and one of the coordinators introduced our group. He shook hands with each of us, firm, unhurried, and when he got to me he said, "Tariq, you're the lead on the flow dynamics side." I blinked, "Yes, sir." I read the technical summary. The passive pressure system, I had a few questions about that, looking forward to getting into it. And that was the moment I stopped being nervous. Not because the nerves evaporated, but because something in his directness, the simple fact that he'd actually read the material, that he had specific questions, that this was clearly not performative, shifted the whole feeling of the room. This was going to be a real conversation. I thought of Marcus's grandmother, the half-mile walk to the well, 63 years old. I thought, good. Let's talk. There's a particular kind of silence that happens in a technical session right before the work begins. It's not uncomfortable. It's not the silence of awkwardness or ceremony. It's more like the pause before a dam opens, that held breath moment when everyone in the room shifts from performing readiness to actually being ready. That was the silence that settled over the table when Dr. Anand stood to give the opening overview. I was sitting 3 chairs down from Prince William, which meant I was close enough to occasionally catch his expression without being directly in his eyeline. He was listening the way attentive people do, not nodding constantly, not making conspicuous sounds of agreement, just genuinely still and focused. He had a notepad on the table in front of him and a pen in his right hand, but for the first several minutes he didn't write anything. He was just listening. Dr. Anand spoke for about 8 minutes. He gave context, the scale of the global water crisis in post-disaster zones, the gap in current supply chain infrastructure, the specific problem our research group had been trying to solve. He talked about the floods in Pakistan in 2022, the earthquake-affected communities in Turkey and Syria, the ongoing crises in the Horn of Africa. He talked about the window of vulnerability, that 2 to 3 week period after a major disaster when contaminated water sources represent the single greatest public health risk, often exceeding the initial casualty figures if not addressed. He was measured and precise. He didn't oversell the problem. He let the numbers do the work. At one point, one of the policy advisors, a woman with reading glasses pushed up on her forehead in a very direct manner, raised her hand slightly and asked, "When you say contaminated sources, what specific contaminants are we talking about?" Because the intervention design changes substantially depending on the profile. Dr. Anand nodded. Exactly right, which is why I'll ask Tariq to walk through our design parameters, because that's where that question gets answered. So I stood up. I want to be honest about this part. My mouth was dry and my heart was doing something slightly erratic. Not dramatically so, just enough that I was aware of it. But here's the thing about presenting work you actually care about. The caring eventually overrides the fear. At some point, you stop thinking about the room and you start thinking about the problem. And once you're thinking about the problem, you're fine. I'd done this presentation 40 or 50 times in various forms. I knew the material the way you know a road you've driven in the dark, by feel, by rhythm, by all the small landmarks along the way. I walked them through the design, the filtration sequence, first stage coarse sediment removal, second stage activated carbon layer for chemical absorption, third stage ceramic membrane filtration at 0.2 microns, sufficient to remove bacteria, protozoa, most viruses. No electricity, no moving parts beyond a simple float valve, fully gravity-driven. The cost per unit figure was the one that always landed hardest, and it did again here. Fabricated using locally available materials, the unit could be assembled in-country for approximately $40 to $60 per unit. Off-the-shelf humanitarian water purification systems typically run between $300 and $1,200 per unit, excluding logistics. I heard one of the panel members exhale quietly at that figure. I continued. The unit's output, 200 liters of safe drinking water per day, sufficient for approximately 40 people at WHO emergency minimum standards. Modular design allowing units to be linked for higher capacity situations. Assembly time from flat pack, under 90 minutes with basic training. When I finished, there was a short silence, not the uncertain kind, the absorbing kind. Then Prince William leaned forward slightly and said, "The ceramic membrane, where are you sourcing that in your prototype?" "Currently from a supplier in the Netherlands," I said. "But we've identified compatible local production capability in 4 target regions: Kenya, Bangladesh, Haiti, and the Philippines. The clay composition for the membrane can be adapted to local deposits with minimal technical modification. That's actually one of the things we're still refining." He nodded. "Because the point breaks down if it can't be reproduced locally after the initial supply runs out." Exactly. Supply chain dependency is one of the biggest failure modes in humanitarian tech. You get the first shipment in, it works, and then the replacement parts require a 6-week international procurement chain, and the whole thing collapses. He wrote something on his notepad. "Have you tested locally reproduced membranes yet, in the actual target regions? Not field tested in region. We've run controlled comparisons here with alternative clay compositions, and the results are promising, within acceptable performance variants. But in-region testing is the next phase. That requires partnerships and funding we're currently working to secure." "What's the main obstacle there?" I thought about it for a second, because I wanted to answer honestly rather than diplomatically. Access, partly, and institutional trust. NGOs and aid organizations are cautious about committing to new technology without a longer track record, which is entirely reasonable. They've been burned before by solutions that sound good in a lab and fall apart in the field. So the validation cycle is slow. He sat back, looked at me steadily. "So you need proof of concept in a real operational environment?" "Yes, that's the gap." He nodded once, and then looked toward the policy advisor with the glasses on her forehead, and there was a brief exchange of glances between them that I couldn't entirely read, but that felt significant. The session opened up after that. It became less of a presentation, and more of what I can only describe as a proper engineering conversation. One of those discussions where different kinds of expertise start overlapping, and you lose track of who's been speaking. Because Ideas are building on each other faster than attribution can keep up. The technical questions came from every direction. One of the panel members, introduced earlier as having a background in supply chain logistics for UNICEF, asked detailed questions about flat-pack dimensional tolerances and air freight weight limitations. James fielded those, talking through our packaging design in detail, the way we'd engineered the unit to sit within standard humanitarian supply pallet specifications. A woman from what I understood to be the Foreign Commonwealth Development Office asked about community training requirements. How long? Who would deliver it? In how many languages had we produced instructional material? Nadia handled that section. She'd built the training protocol herself, and she talked about it with quiet precision, including the visual instruction format we developed to work across literacy levels. At one point, the discussion turned to something slightly harder to quantify: community uptake. Not whether the technology worked, but whether people in disaster-affected communities would actually use it and trust it. Marcus spoke to this one. He didn't use data, he talked about his grandmother. The room went quiet in a different way when he did that. He was very matter-of-fact about it, no performative emotion, just honest detail. The walk to the well, the daily weight of it. The way water scarcity reshapes the structure of a whole day, especially for women and older people. He said that when you design something like this, you can't just think about filtration rates and unit costs. You have to think about what it means to a person to have safe water available where they are, rather than somewhere they have to go. I watched Prince William during this. He was very still, listening with his whole face. When Marcus finished, William said, quietly, like he was thinking aloud rather than making a statement, "That's the part that doesn't get talked about enough in the engineering literature. The weight of the problem for the people living inside it. The daily grind of it." Marcus looked at him. "My grandmother is in her 70s now," he said. "She's still walking to the well." A pause. "Right," said William. He didn't say anything else for a moment. He just wrote something down. About 90 minutes into the session, one of the coordinators quietly brought in more tea and some water. Nobody really stopped talking to acknowledge it, which felt like a sign that the conversation had found its own momentum. The moment that stays with me most vividly, the one I think I'll be telling people about for years, came just past the 2-hour mark. Prince William had been asking questions in a way that felt increasingly specific, increasingly probing. Not challenging, not trying to catch anyone out, but genuinely working through the problem. At one point he asked about the chemical contamination threshold, specifically in relation to arsenic, which is a massive issue in flood-affected regions of South and Southeast Asia, where naturally occurring groundwater arsenic gets mobilized by flooding and enters previously safe sources. I answered what I could, but the honest answer was that our current activated carbon layer performs well against organic chemical contaminants and heavy metals at moderate concentrations, but high arsenic scenarios were at the edge of our design parameters, and we knew it. "So there's a gap," he said. Not accusingly, just nodding it. "Yes," I said, "there's a gap. For high arsenic contexts, the unit in its current configuration would need an additional coagulation flocculation stage, which increases complexity and cost. We've modeled it but not prototyped it." He looked at me for a moment. "I appreciate you being straight about that. I've sat through a lot of presentations where the limitations get softened." "The limitations don't go away just because you soften them," I said. "They just show up later in a worse place." Something shifted in his expression, not quite a smile, more like recognition. "That's a useful way of putting it," he said, "for a lot of things." There was a break at about the 2.5-hour point. People stood, refilled cups, stretched. The formal structure of the session relaxed slightly, and conversations broke into smaller groups. I found myself standing near the window with a cup of tea, looking out at the courtyard below. Prince William came and stood nearby, not in a managed, scheduled way, just organically, the way people drift at these things. He asked me something I wasn't expecting. How did you end up in this specific area? Water systems in disaster zones. It's a particular focus. I told him the short version, where I grew up, the water situation, the way it shaped what I thought engineering was for. He listened without interrupting. Then he said, "Do you feel like the engineering world is set up to reward this kind of work? Or does it still feel like you're pushing against something?" I thought about it honestly. Both, I said. There's more interest than there used to be. Climate impact, disaster response, it's taken more seriously in the research funding landscape. But there's still this gravitational pull toward solutions that are marketable at scale in high-income contexts. The economics work differently. A filtration unit for a refugee camp doesn't have the same commercial incentive structure as a water purification product for the consumer market. He nodded slowly. Which means you need policy infrastructure to compensate for that market failure. Yes, exactly that. He looked out the window for a moment. That's what these review processes are trying to build, not always successfully, but trying. I believed him. That was the thing, standing there with a cup of tea looking at a courtyard in central London, talking about arsenic contamination and market failure and my grandmother. I genuinely believed he meant it. We went back in for the second half of the session. More specific, more technical in places. The FCDO representative outlined a potential field evaluation pathway in partnership with 2 existing NGO networks operating in flood-prone regions of Bangladesh. The logistics advisor raised the possibility of a coordinated procurement trial through a Commonwealth humanitarian supply mechanism. These were not promises. Everyone was careful about that, appropriately careful. But they were concrete next steps, and that was more than we'd had when we walked in. At the very end, Prince William spoke for a few minutes. Not a speech, just a summation of what he'd taken from the session. He talked about the gap between good ideas and implemented solutions, and how that gap was where most genuinely useful innovations get lost, not because they don't work, but because the pathway from proof of concept to field deployment lacks the infrastructure it needs. He said he thought what our group had built was promising enough to warrant investment in that pathway. Then he looked around the table and said something I didn't write down but haven't forgotten. The people who most need this aren't in this room, which is why what happens after this room matters more than what happens in it. The room was quiet for a moment.